This demonstration is entitled XQuery versus TCSQL. These are two technologies used to query graphs. XQuery today is considered the de facto standard in querying graphs within the context of a relational database system. If you've ever used XQuery, you found certain challenges. For example, when you specify an XQuery, you have to know in advance whether you're looking for elements or attributes. A second challenge, if you run a query that needs to cross different kinds of XML documents, you end up having to hard code the structure of those documents in your query specification. We're going to demonstrate the use of TCSQL, which overcomes many of the challenges we see in XQuery. In particular, using TCSQL, it is possible to write queries without having to have any hard-coded knowledge as to the structure in those graphs. In this demonstration, we see three windows. On the left here, we see a text document, shiporder.xml. So this is basically an XML document. To the right, we see Microsoft SQL Server Analyzer running. And below that, we see an application called XML to TCSQL. What we want to show here in this demonstration is how to import this XML document into a relational database. And we're going to examine two approaches. The first approach is to simply create a standard relational table. In this case, we're going to create something called shiporder, which has one column called XML col of data type XML. And we're going to execute the following insert statement. You see here a path to the XML file shown on the left here. Below, we see another approach here. We have an application called XML to TCSQL. What this does is read this XML file into what's called a soft schema structure. If you've seen any of the presentations, they talk about 6 underlying TCSQL tables that form what's called a soft schema. TCSQL is used to represent graph problems. An XML document is viewed as an object graph. And so this application will read this XML data into the corresponding soft schema relational tables. Now we've actually imported this file into both structures here. So we've already executed the insert statement shown here, and we've already executed the XML to TCSQL application. What we want to show here is the difference between querying the two structures. So the first thing we want to show here is how to query the ship order table here. And that's shown in the following select statement here. So if we execute that, and what we're going to do here is in the XML file here, what we want to return is the order ID and a list of all the items, all the titles here shown in this XML document. So we're going to accomplish that by executing the following select statement here. And so we see two records returned as expected here. Let's do the same thing, the same query, only instead of querying the ship order table, we're going to query the underlying soft schema table. So we will be querying this TCSQL object table, representing the nodes of this object graph, and the table called TCSQL object TC, representing the transitive closure of this graph. So upon executing this query, we get the exact same results. So that's a good thing. But there are some significant differences between these two approaches. In the first approach, we're using XML data type methods that are very specific to XML. So we see this method here called value and another method called nodes. Now the relational model is based upon relational algebra, which supports the notion of projection, restriction, and join, plus 3 set operators, union, intersection, and set difference. By supporting XML data types, we've now added a whole new slew of different kinds of methods needed to process XML kind of data. So I claim if the problem at hand involves simply parsing XML data, then using these methods is a very good approach. If the problem at hand involves being able to take some information from your XML document and joining it to standard relational data in standard relational tables, then this approach can be rather cumbersome. Compare and contrast that to the approach below, which uses the soft schema. You'll notice the only thing it's doing here are simple joins here. So it's only using the classic relational kinds of operators here. Another significant difference here, you'll notice here in both the value and nodes methods here, this XPath specification here. Now internally, when processing a path, what happens is a recursive function is executed. So recursion is known to be rather slow. Compare and contrast that to the use of transitive closure, which is going to be much faster. A third significant difference here is that in the query above here, you have to hard code knowledge as to the structure of this graph. So I have to know up front whether order ID is an attribute or an element. So we see here in the specification we have an @ sign indicating that order ID is an attribute. And in other cases where it's an element, like item here, we don't have an @ sign here. So you have to know up front whether something is an attribute or element. In the query below, attributes and elements are treated uniformly, so we don't have that complication. So in summary, what I claim is that if the problem at hand is one involving processing both XML data and standard relational data in the same context, in the same environment, the approach below using a soft schema is much preferred.